Okay, so here's what we got. We got derivatives of both logs and exponential equations. Let me show you how this works. 3 parts to derivatives of logs. The first is the item in parentheses goes in your denominator. Second thing is also in your denominator is the natural log, and it's always the natural log of whatever your base is, in this case, a, times the derivative of the item in parentheses. Now this part goes in your numerator, and the derivative of x is 1. All right, so chain rule, okay, that you do at the very, very last step, but that's the only part that's not in the bottom. Okay, it actually goes on the top. Now you're used to this other one, the derivative of the natural log of x. Most people know it's already 1 over x, but why? Well, if I follow the same rules here, keep in mind that the natural log of x is the same as log base e of x. That's the same thing. So if I'm following the same rules, and I'm taking the derivative, I'll just write the answer up here. Again, log base e of x is the same as natural log of x. This guy comes down, times the natural log of e, okay? And then on top is the derivative of whatever that item in parentheses is, and that is 1. Now, you can leave it that way if you want. That would be 100% correct. However, the natural log of e will go away, and you're just left with 1 over x. Okay. Similarly, exponentials have pretty much the same rules. The only thing is that everything goes in the numerator. So the derivative of a to the x will just be a to the x, okay, keep it in your numerator, times the natural log of whatever your base is, a, and then times the derivative of your power. Okay, in this case it's x, okay, which is 1. Okay, so this will go away. Your overall answer would be a to the x times the natural log of a. All right, and if you had that same rule here, again, all you do is you repeat it, e to the x, times the natural log of the base, which is e, times the power's derivative, which is 1. And all of those will go away, and you're just left with e to the x. That's why the derivative of e to the x is e to the x. Okay, find the derivative. We have all kinds of things here, okay? Derivative sine of 2x, and most of these will have some form of chain rule, and that would make sense because these parentheses have some items in there other than x, okay? Notice that a lot of them look the same, like the first one, the fourth one, and the fifth one all look pretty close, especially the fourth and the fifth. Okay, so here, again, we'll do a chain rule. That's y prime. And I'm just going to worry about the cosine, the sine, which is derivative is the cosine. And then remember, I'm going to take the derivative of the item in parentheses. So that's always the last step. Derivative of 2x is 2. Okay. This one, and you'll notice that there's a stronger variety as we work through these. They get a little bit more unique. This one matches what I have right here. So the first thing I'm going to do for y prime is I'm going to put everything that's in the parentheses on the bottom. Okay. I don't have to write the natural log of e because I already know that the natural log of e is going to be 1. Okay, sorry, that was over here. Okay, but I must take the derivative of the bottom piece. And what's in the bottom? A 4x squared. The derivative of that is 8x. And then you must simplify. 8 over 4 is 2, and x over x squared gives an x on the bottom. All right, third one is an e to the x, one like this. These are my favorite because remember, e to the x's derivative is just itself. Okay, so put the 7x with it. However, you got to multiply it by the derivative of the power. And the derivative of the power is 7. Okay, and then typically we would put those together. All right, now 4 and 5 are a little bit different. Okay, they both involve a product rule, but they occur at different locations. All right, so if I look at this first one, this has a time sign between the two terms. Okay, there's your first term, there's your second. And so you will use a product rule in the beginning. So be careful with that. And my hope by now, as we practice this, hopefully you know that the derivative of the square root of x is 1 over 2 square root of x. Okay, so if you can do that more naturally in your head, then that is fantastic. Okay, so first of all, it's not sine of x, it's the sine of 4x. That's its own term. First, times the derivative of the second. Now the derivative of e to the square root of x, that is nasty. Okay, but what I'm going to do is rewrite it, just like I did here. Rewrite whatever you have. E to the square root of x times the natural log of e, which is the second part, which again is always 1. Okay, times the derivative of the power, and the derivative of the square root of x, which we wrote right here, is just 1 over 2 square root of x. Okay, so that is the first part. Okay, and these are all time signs. Now, second part, first times root of the second is the first part. Second times root of the first, so e to the square root of x. Okay, and derivative of the first derivative sign is cosine. Okay, and then chain rule, multiply that by 4. Here's what I'm going to share with you. I know the back of the book won't have this written this way as an answer, but you do not have to simplify that. Okay, if you wanted to, you could clean up maybe the numerator here and get rid of the ones, put this all in one denominator and that, and sorry, one numerator up on the top and this denominator on the bottom. You could, but you don't have to. Okay, this is enough for where we're at. All right, now notice this one looked just like that one. The only difference is that you have parentheses in different locations, and that makes a huge difference. Okay, you still have a chain rule, but it occurs more in the beginning. Okay, so this is y prime. There is no multiplication. Okay, there's no product here except for the inside piece. So let's go with this. The derivative of sine is cosine. Okay, and then this piece, now that we've done the first part for the derivative, you recopy it inside here. Okay, don't skip that part, recopy it, and now you have to do the chain. Okay, now this chain is bad. I'm going to put this in another color because it's long. And we'll do this in orange. Okay, so chain rule here. Okay, so this is 4x, okay, times this guy. All right, so the derivative of e to the square root of x, we've actually already done that. Okay, it's itself, okay, times the natural log of e, which we know what it is, and then times the derivative of the square root of x, which is what we said right there, okay, times 1 over 2 square root of x. Plus, because again, this is a product rule, seconds, okay, times the derivative of the first, and the derivative of 4x is 4. All right, now honestly, I don't want to do anything really further. Okay, you can't simplify stuff inside here with things on this part. Okay, this does clean up a little bit. This is really 4x e to the square root of x all over 2 square root of x. That doesn't simplify. And then plus 4 e to the square root of x. Almost had it. All right, last one is a chain rule. Okay, you can stop right here at this first line. Okay, so chain rule from a quotient rule. So f prime of x, and I don't want to run out of space, and I'm probably going to get rid of orange super quick. I don't like it. Okay, so sine of x is on the bottom, squared. All right, so low times the derivative of the high. So derivative of the high is 1 over this item times the derivative of this. So the derivative of x cubed is 3x squared. Right? Now this x squared would cancel with some of those x cubes down there. So keep that in mind. We'll worry about that in a second. Okay. Minus, so low times derivative of the high minus high times derivative of the low. And derivative sign is cosine. Really fit that in. Okay. On top, there's not a whole lot you can do. You can basically call this sine x over x if you want. Just under the quick thing, I'm not doing the whole thing. And this is the natural log. That can't simplify any further. So natural log of x cubed times the cosine of x. Okay, all over sine squared. Got it in there. Okay, great. All right, next piece. Find the second derivative of, okay, f of x equals 3 times 2x minus 5 to the 4th. Okay, so here's what I'll do. F prime of x. Okay, 4 comes out in front. Okay, now to the 3rd power. Okay, am I done? No, remember chain rule. You got to multiply that through by a 2. Okay. In the end, it may be to your advantage to clean it up just a little bit, only because you need a clean problem to start with in order to do the next piece. Okay, so 3 times 4 is 12, 2x on the 3rd, yeah, chain. All right, so now I'm going to do the second derivative. Okay, I'm going to move the 3 out front. 3 times 24 is 72 times 2x minus 5 to the 2nd power, because I dropped from a 4 to a 3, now 3 to a 2, and then multiply this by the derivative of the inside piece. 144 2x minus 5. Awesome. Let's keep going. I feel like I just skipped one. I did. How'd that skip? Skip 2. All right, evaluate the derivative. I'm sorry if you had to skip around. That was not my intention. Evaluate the derivative at the given points. Okay, so remember this is really 2x minus 3 to the 1/2 power. So if I take the derivative, okay, move the half out front. Okay, subtract 1 to that. Okay, so 1/2 minus 1 is -1/2. And then again, times the item in the inside. Derivative of 2x minus 3 is 2. Okay, conveniently, those will go away. And you're left with 2x minus 3 to the -1/2, which if you put on the bottom, makes it look a little bit better. Okay, now, why is this a value? Well, I need to find the derivative at this point. So I'm going to input 6. Okay, so this is g of x being derivative. That's not a verb. Doesn't make sense. Being derived. And this is g prime of 6, which is 1 over 2x. Ooh, let me change that. I'm just going to call it 6. 2 times, I'm going to fix that. All right, 2 times 6 minus 3 to the 1/2. And really, you could stop there because you inputted your x like you're supposed to. But if you were to finish this, this is 1 over the inside piece here gives you 9. Okay, and 9 to the 1/2 is really a third. It's really 3, which gives you a third. All right. Same idea here. You have a fraction here, so there's a quotient rule that involves a chain rule. I think we've done this. I think I wanted to. That's the one where I had that ugly mistake on. Okay, or it jumps to the next screen. So h prime of x. Okay. Okay, so I'll do the first part. I like doing the bottom part first. But it's low times the derivative of the high. Derivative of 2x minus 8 is 2. Minus high, which is 2x minus 8, all over the low, which is negative 2. All right, so I'm leaving this bottom as is. Okay, this top piece, gosh, I don't know if it's to our advantage to actually distribute, or maybe it's to our advantage just to put the point in. Okay, all we have to do is plug in a 3, and you know, I'm going to do it now. Okay, so I'm going to input 3, and I'm going to do it where this x is here as well, because that's where those go. I don't know if you'll see this well. Let's try another. We'll do red. All right, so 2 times 3. And anytime I see an x, I'm going to replace it with 3. Okay, so there we go. And let's see, this is 5 minus 6, which is negative 1 squared, which is 1. Nice. Okay. And typically, again, you can leave it like this, but for example, you may have to plug this slope into the tangent line at 3, and that makes things really ugly. So this gives you negative 2. Yes. And this part here minus is 6 minus 8 is negative 2 times negative 2 is a positive 4, which goes here. So in the end, you get, I believe, negative 8. Looks good? Okay, great. Let's keep going. All right, getting close to the end, but problems that are familiar to us. Find the equation, the tangent line to the graph, f of x equals the cosine of 4x at the point pi over 2 comma 1. Okay, so remember, equation of the tangent line looks like this. You gotta put something in for y1. We need something for m, and then it's x minus something right here. Okay, so here's my x value, is pi over 2. Here's my y value, which is 1. I didn't even have to plug anything in to get that. All I need is the slope, basically, of this f of x function at pi over 2. Okay, so f prime of x is equal to, derivative of cosine is negative sine. Okay, and then multiply the 4x by 4. Okay, so this is pi over 2. That's being multiplied by this 4. Okay, now 4 times pi over 2 gives you, I think, 2 pi. Okay, and what does that give me? Well, the sine of 2 pi is 0 times 4, which is 0. How anticlimactic to like go through all that slope stuff and give us 0. So that goes in here. You could distribute this through. It basically gives you y equals 1, but I would just stop, because that is exactly what you're supposed to do. Okay, and you were able to leave it that way, and just because they give you an ugly slope doesn't mean that you have to do more work. Okay, cool. Guess what? We did that one. Awesome. Last item here. This is the same type of question that I had before, and the only difference is that this should involve a chain rule. Okay, so let's start with this. First of all, don't plug in the number. Don't just take 3 and input it in for the x. They ask for h prime, which means you need to expand this. I'll do it just above it. And it's nothing more than the formula that you learned on the very first slide. Okay, so you remember, you take the derivative of the f term, okay, and then recopy the g of x behind it, and then multiply by g prime of x. Okay. Now, the only difference in the end is that we have to input, this time, a different number, 3. All right, so we have f prime of g of 3 times g prime of 3. Okay, and I don't mean to work upwards. That's kind of not the way we do math, but I just wanted you to be able to see it close to where the question was. Okay. All right, now let's find what g of 3 is, and let's find g prime of 3. Okay, remember primes mean you're going to have a slope. G's are over here. And I don't know if I'm supposed to use I'll use this one for this guy right here. Okay. We'll use this one for question 3, and we'll use this one for question 4. All right, so g of 3. G of 3 is 2. Here's g, here's 3, is 2. So this becomes f prime of 2. And then g prime of 3, well, here's g prime down here of 3 is 4. Okay, now be careful, don't multiply those. This is still an input value for the f prime. So let's do that real quick. F prime is right here. F prime of 2 is -1. Times 4 is -4. So I'm going to write that just above it, -4. Okay. People are like, when can I stop doing work? Well, you could have done it right here. Once you have no more f's or x values, that's when you can do it. Okay. All right, now this one's the reverse. This one is the g of f of x. So when you take the derivative, okay, it's the derivative of g times f of x, okay, then times f prime of x. Okay, so that is our chain rule. And now we're going to input 7.5. Okay, so you got g prime of f of 7.5 times f prime of 7.5. Okay, now f of 7.5, let's take a look over here at 7.5. Here's 7. 0.5 is right about here. I'm going to trace it upwards. And it does actually touch something nicely. And if I go across, it looks like it touches at 5. Okay. And I forgot some parentheses. Let me put those in here. Sorry. Okay, so f of 7.5 is 5. Okay. F prime at 7.5 says, what is the slope at this point? And if you look at this line, it looks like it's about, well, it looks like I got to go up 2 and over 1. So 2 over 1. And so that leaves me with g prime of 5 times 2. And okay, so now I'm going to look at g, which is this blue function. And at 5, it's right here. G of 5 would be 3, but it doesn't ask for that. It asks for g prime of 5, which means I need the slope at this location. And you can see that that is a slope of 0. So once again, we have an answer of 0. Mix these problems up. Okay, look at that, we're done. Okay, so there's your assignments. That's big, okay? Make sure you know what this is. This is every other odd, okay? So start with 7, skip 9, do 11, skip 13, do 15, and so on. Same thing here. That looks like a lot of work, but when you subtract those, it's about 15 problems, okay? So, all right, this is due in many days, okay? So don't think that you have to have this done by tomorrow, especially with maybe one that you're already currently working on. So just give your best. If you have some questions, holler at me, and we will chat. All right, hope you're having a great day, and we will talk to you soon.